Okay, let f be the function defined on the closed interval 0 to 7. So I always read slow and careful. So here's x equal 0 to x equals 7. So that makes sense. The graph is f. This is f. Good. Consisting of 4 line segments. Let G be this. Again, I know this looks like a lot of problems you've solved, but I force myself to not have a bad habit of solving problems from memory. I always solve problems from concepts. So they want me to find G of 3. So I go to G of 3. It's going to equal the integral from 2 to 3 of f. So here's f, starting at 2. The values of f are all positive. So all of this area counts positively. This is 1 by 2. So that area is 1. This is 1 by 2. So that area is 2. Therefore, I write down 3. And they give me 1 point. Sorry for the delay, just checking the scoring guide to make sure they had that correct. Now G prime of 3, which means I need to take the derivative of this. So I need this formula. You don't have to write this down, I'm just writing it as explanation. This has to be dx because I'm taking the derivative of g itself. But since g is an integral, that's the same as taking the derivative of this integral. Oops, that's a 2. And according to the formula, my g is 2, my h is the x, my f is just f. So this is going to equal f of the upper limit multiplied by d over dx of that upper limit minus exactly the same thing with the lower limit. Again, this statement in blue does not need to be written. You can do this in your head. Just make sure you're using the rule up here. So I find that g prime of x is, as in many problems in the past, this is just equal to f. But again, I don't solve the problem by remembering problems. I solve the problem by remembering concepts. That's how you prevent the AP test writers from, or at least try to prevent them from fooling you. So now I know that g prime of 3 must equal f of 3. Look up here. F of 3 is 2. I'll give you 1 point for that. Next, we need to find g double prime of 3, which means that's going to be f prime of 3. So here's 3. F prime of 3 means the slope right there. This line goes down 4 over 2. Down 4 over 2. I can stop there to get the last point for this part A, which was worth a total of 3 points. Okay, part B. Find the average rate of change of G. Look at my golden notes. I see average rate of change of G is right here, except that I'm using G, so it's going to be G of 3 subtract G of 0, all divided by 3 subtract 0. I found G of 3 in part A. turned out to be 3. So I'm going to need g of 0. So g of 0, again, as long as I'm writing, I'm making good progress, so I just keep writing. This will be 2 to 0. When I stop writing, I need to move on to a new problem. I don't want to do that integral because it's backwards, so I'll flip it, multiplied by -1. So now 0 to 2. So from 0 to 2, the graph of f is always positive. So all of this area counts positively. We are 2 by 4. So this is going to be 2 times 4 multiplied by 1/2. Which turns out to be 4. So g of 0 is 4. So I now know, and for the average rate of change of g, that's going to equal g of 3, which was 3, g of 0, which is 4, oh, big mistake. I gotta slow down. Don't forget the negative. -4, all divided by 3. You can leave it like that, they'll give you full credit. If you kept going, you would get 7/3. So again, make sure you're going slow and careful, reading your work. 2 points for this problem. They would give you 1 point, well, kind of a couple different ways you can get points here. 1 point for finding this, that's for sure. If you had this written on your paper, but you never found this, they would give you 1 point but not 2 points, just one of the two. So if you have both the formula and the final result, you get 2 out of 2. If you found g of 0 to equal 4, but you didn't find the final result, I think you'd still get 1 out of 2. But a total of 2 points on this problem. That was part B. Again, don't watch your work carefully. I would have lost that point. Okay. Find the x-coordinate of each point of inflection on G. So I'm right here. G has a point of inflection when G changes concavity, or G prime changes increase to decrease. So I already figured out that this is G prime. So right here, G prime changing increase to decrease, right here as well. You get 1 point for each, total of 2. Okay, part D. Let f be the function satisfying this. Tell us f of 3 is 25. Find f double prime of 3. Okay, so I've got f prime of x. So I'm going to have to use the product rule. So f double prime, second function, second of the two multiplying functions, second of the two factors, multiplied by the derivative of the first. Again, this is dx on the bottom here because we are taking the derivative of a function whose input variable is x, plus the first function multiplied by the derivative of the second. This is going to equal, this is 1 here. So I get root f of x plus x. The derivative of the square root of something is 1 all over 2 times the square root of that something multiplied by the derivative of what is inside the root. So my f double prime of x is going to equal square root of f of x plus x all over 2 square root of f of x. And then the derivative of f is f prime of x. Okay, if you get that far, they'll give you 1 point for correctly on getting that far. On the AP test where this problem was actually given, they actually gave you 2 points, but again, I'm trying to make the practice test just a bit harder, a bit longer than the actual test. It's better to be that way than the other way around. So anyway, now I'm supposed to find f double prime of 3. So f double prime of 3 is going to equal square root f of 3 plus 3 divided by 2 square root f of 3 and then f prime of 3. So I've got to go figure out what f prime of 3 is. So here's my formula for f prime. So f prime of 3 is going to equal 3 square root f of 3, which is going to equal 3 times the square root of 25, which is 5. 3 times 5 is 15. So that means back over here, f double prime of 3 is going to equal square root of 25 plus 3 all over 2 times the square root of 25. If we get parentheses here, f prime of 3 is 15. I would stop there. They'll give you the other point. So this problem, part D, was worth a total of 2 points. Checking my work real fast. If you had kept going, the answer turns out to be 19 halves, but you don't need to keep going, of course. Part E. Write an expression for y by solving the differential equation. So I'm solving a differential equation. My differential equation contains the output variable y, therefore I must use the SASSY method. So I have dy over dx equals x times root y. First step is always the same. Multiply both sides by dx. Now we move the root y. If I get this far, they'll give me 1 point. Okay, finding the antiderivative of a root, not so easy, so we're going to remember that, let's write it over here. 1 all over root y the same thing as 1 all over y to the 1/2. The same thing as y raised to the negative 1/2. So over here we have antiderivative y to the negative 1/2 dy equal to antiderivative x dx. So this becomes y to the negative 1/2 plus 1. Negative 1/2 plus 1 is 1/2. This is over 1/2. This becomes x squared over 2 plus the constant. So if I get that far, I get one more point. Okay, you're going to erase this now. Okay. Dividing by 1/2 is the same thing as multiplying by 2. Y to the 1/2 is square root of y. So now what I have is 2 square root of y is equal to x squared over 2 plus the constant. So use my initial condition. So I take 2 times the y value, which is square root of the y value, which is 25, must equal the x value, which is 3, squared all over 2, plus the constant. This is 2 times 5. Right here you get a point for plugging in to solve for c. So I got 2 times 5 must equal 9 over 2 plus the constant. Therefore 10, subtract 9 halves is c. Get that far, you get another point. Leave it like that, but for the isolate step it's a little easier to have it written differently. So let's see. This would be 20 over 2 minus 9 over 2. So 11 over 2 is C. So next step is the isolate step. Let's copy this over. Get rid of this. Okay, so for the isolate step, we'll start with this equation and the value of C. So I get 2 root y must equal x squared over 2 plus 11 halves. This one looks pretty easy. Often I'll skip the isolate step. This one I'm going to keep going. So let's get rid of this. This was on the previous page here. So to get the y alone, divide both sides by 2. So get root y, it's going to equal. Here's where you don't have to do any simplification, so that helps. Divide both sides by 2, the whole entire right side by 2. To get rid of the square root, we square both sides, and that's it. So that one was certainly worth doing the isolate step, because it came out really fast. Okay, part F. If x squared, so we got this, we're supposed to show this. Okay, so you have to take the derivative of both sides. So this is going to become 3x squared The negative, better put a big parenthesis. This is the product rule. So it's the second times the derivative of the first plus the first times the derivative of the second plus the derivative of this is going to be 6 y to the first power, then dy dx. And the derivative of 7 is 0. This problem is worth 2 points. I've got to get a little bit further. One more step and they'll give you the first point. So we have 3x squared minus derivative of 2x is just 2. So this is going to be 2y plus, I just saw my mistake, so that's good news that I noticed. Doesn't help to do the same thing twice. That's what I should have had written there. Good example of going slow and careful, caught that one. Should have written 2x times dy dx. So 2x times dy dx plus 6y dy dx, all equal to 0. Get that far, they will give you 1 point so far. Keep going. So we have 3x squared. Distribute the negative. So negative 2y minus 2x dy dx plus 6y dy dx equals 0. So we're going to keep these two things on this side, move these two to the other side. So we're going to get 6y dy dx negative, so minus 2x dy dx equals, when these move over, the signs will switch. This will be 2y subtract 3x squared. Factor out the dy dx. End up with 6y subtract 2x. Divide both sides. And now I have what they have, except that I have the opposite. So that's easy to fix. Remember, negative 1 divided by negative 1 is just 1. Multiplying anything by 1 doesn't change anything, it just changes the appearance. So if I take this and multiply the top and bottom by negative 1, I'm not changing anything, I'm just changing what it looks like. So this is going to be, shouldn't have that leading equal sign, that looks a little funny. Dy dx equals 3x squared minus 2y all over 2x minus 6y, which is what they said I was supposed to show. So I've done that, so I get another point on this problem. Common question is, how much do you have to show? I think you could skip this line just fine, as long as you have this line. For the rearranging, you could probably go from this line clear to the end and they'd still give you both points. So you don't really have to show that many steps. Show as many steps as you need to show to avoid making a mistake. Otherwise, you're fine. That's the end. Let's just make sure here. So part F was worth a total of 2 points. Back here, part E was a total of 5 points. Yep. That puts us at 7 so far. Part D was 2 points total. Puts us at 9. Part C was 2 points total. Puts us at 11. Part B, 2 more points. Puts us at 13. And then part A was 3 points. That gives us a total of 16 for question 1.